Thanks, everyone. Thanks for coming to this session. We're going to be discussing LLMs. You can't have a security talk without talking about AI in 2024, so we're going to continue that trend and look at some of the research that we've been doing at Aikido with our research team, and also how we've been integrating AI, specifically in securing the open source supply chain. So a little bit about me first. If you're wondering where my accent's from, I'm from Aotearoa, or New Zealand. I now live in the Netherlands, but I work for a Belgian company. I just like to keep everyone guessing, so no one has any idea where I'm going to be. And you can find me anywhere on social media at the handle @AdvocateMac. And this very quickly, I have one slide on the person that pays me, the company that pays me. So I work for Aikido. If you haven't heard of Aikido before, we kind of base ourselves on the no BS security tools, specifically focused for developers to help get security done quickly. So I won't talk much about that now, but if you do want to find out more about Aikido, you can find us. We're very well hidden. It's a game to try and find our booth. And if you manage to find it, you get a free demo. But enough about that. So I want to start off by going a little bit into understanding the open source supply chain. Probably a lot of you will be aware of some of this first part, but I think it's important to cover it and cover why the open source supply chain is a huge problem at the moment, and what are some of the blind spots that we're dealing with in security and making sure that we're secure from it. So I think some people have probably already seen numbers like this. Some people say 90, some people say 85. I'm just saying 85, but around about 85, a significant portion of your source code doesn't come from your application. It comes from open source dependencies. And that can mean that often 85% of your source code is relatively unknown to you. And if you have a sophisticated attacker, they can know most of your source code better than you can. And if we take a look at this and how open source dependencies work, we have our application. Our application has a bunch of open source tools that we know. Those open source tools have open source dependencies that they have. They have open source dependencies, and I'll stop there to be polite, but we can go down 30 layers. And then obviously we have like some third-party services that maybe we're using in our application. It's closed source, but still integral to our application. Now, this all looks very clear. We can paint a very nice picture of this. I can understand it, and it looks like I'm going to be able to manage it. But this is a little bit of a lie, because if we were to reflect this accurately, it would look a lot more like this. And that is because we have open source tools that are dependent on each other. We have third-party tools that are dependent on open source tools. And it's very, very difficult to even understand how all of this fits together. So then if we have something like perhaps one of these open source tools all the way down in our supply chain gets vulnerable. Let's give this a random name. Let's just call it log4j, just for fun. And if this component becomes vulnerable, then obviously it can have an upstream effect. It can turn your third-party services vulnerable. It can turn your other open source components vulnerable, which obviously turns your application vulnerable, but you may not even be aware of it. You may not understand how that fits into your supply chain. It's a very difficult problem to solve. And this is why open source security and the open source supply chain specifically is such a big problem and such a difficult challenge that we need to tackle. Now, I'm sure everyone's probably seen this meme before. This meme became so popular that it actually sparked a term, which was called the Nebraska problem. And so what this is you have this whole infrastructure that's being held up by a random project that's being thanklessly maintained by someone in Nebraska. And the Nebraska problem is basically that we have very limited control over our application, over our infrastructure when we deal with this. Now, what's really funny is after this meme kind of became viral, there was an article, someone actually found an open source maintainer in Nebraska that has been maintaining a tool since 2003. So I thought that was very funny. So the Nebraska guy actually exists. He's a real person. But that's kind of the Nebraska problem in a nutshell, is we need to really understand how all this fits together. And if one component fails, it can all kind of come crumbling down. So it's really, really important that we understand our open source supply chain, that we understand where we have vulnerabilities, and that we understand how it all fits together. And if we have darkness in this, if we have things that are lurking in the shadows that we're not aware about, it can make the whole thing fall apart. So if we take a closer look, some real-life examples of the Nebraska problem in action. There was a dependency called UA parser that was around, and this was a very, very popular dependency. So it had 10 million weekly downloads. It had 56 versions, so it has history of being maintained. It's got a lot of dependence on it. So if you were looking at introducing an open source component into your application, into your supply chain, this passes every single smell check, right? This looks like a very solid project, and this was being used by massive companies like Meta, like Google in their applications. So there's no reason why you wouldn't use this application or this open source component. Now, this is one of those projects that was being thanklessly maintained, not by someone in Nebraska. This was being maintained by a guy called Fishal. And because of that, we put a huge amount of trust in all of these maintainers that are often doing this for free. So I also want to say that I'm not slacking on open source maintainers. We very much appreciate them. But this got posted in a Russian hacking forum that someone was selling an account on NPM. Now, this account didn't have two-factor authentication, and someone could buy this account for around about $20,000. And if they bought it, then they could basically have control over these projects. And I'm sure you've probably figured out whose account this was. This was Fashal's account, the maintainer of UA parser. So someone bought this, and then they were able to turn UA parser malicious by injecting a lot of malicious code. And in this case, there was a crypto miner and a credential stealer that were added into UA parser. And they did a lot of sneaky things, like they released 5 versions very quickly to make it feel like you're really falling behind in kind of updating so you had this urgency to update into the latest versions, but all of those were malicious. And this then becomes part of that problem of, if you had UA parser in your supply chain, what do? Well, the first thing is you need to understand that this happens. Now, if you're not part of that Russian hacking forum, how else do you understand that this project has become vulnerable? And typically, we do this through things like CVE, common vulnerabilities and exposures. So a CVE is a report, and this is a CVE for UA parser, where we can let everyone know that this particular package has vulnerabilities inside it, that we shouldn't be using this version of this package. And these CVE reports have really made up a huge part of our open source security. And we really, really heavily rely on them. So if we look at some other ones, here we have one from the Linux kernel. Now, with the UA parser example, it was malicious. But CVEs, more often than not, are not malicious. They're just vulnerabilities. They're just mistakes that happen in open source, right? You have vulnerabilities and it happens. It can happen to everyone. This is one that was in the Linux kernel. It was nicknamed Dirty Pipe, and was a very significant vulnerability that came through, but it wasn't malicious, but we still need to understand how to handle it, because as soon as ill-intent actors or malicious actors find out about these vulnerabilities, then they go off and they try and exploit them in production. I've already mentioned this one. This is probably the world's most famous CVE. This CVE is for Log4j, for the Log4Shell vulnerability. So a lot of people used to say, everyone remembers where they were on 9/11. I remember where I was on the 10th of December, 2021. It was a very bad day. And that was when this Log4Shell came out. If you're not familiar, this is a vulnerability that allowed a remote code execution. And because it was so embedded into Java applications, nearly the whole internet was at some way vulnerable to this. So how do we find out if we're vulnerable to Log4j? Well, there's a CVE report. We understand that CVE report, and we can check to see that we're not using that vulnerable component. Now, ironically, this is actually a much harder challenge than we seem, because in 2023, this time last year, someone did an analysis to find out how much of the internet is still vulnerable to Log4j, and it turned out that 30% of the applications that were running Log4j were still running a vulnerable version. And this is particularly true for this case because the vulnerability had such a long history. where it was if you were using any version of Log4j, basically from the start to the latest releases before the CVE, then you were vulnerable to it. So this kind of helps show us the Nebraska problem, that we can still be so vulnerable to this, even when there is a CVE. But CVEs are basically the best way at the moment for us to solve this problem. And how this kind of system typically works is a vulnerability is found, and I think it's important to say that vulnerabilities are sometimes found and disclosed by maintainers themselves, but often, particularly for big projects, they're found by security researchers, by research teams, by other people that submit the vulnerability on their behalf. So that's really quite important. A CVE is then created once that vulnerability has been found, and then we typically rely on tools like SCA tools, stands for Software Composition Analysis tools, to help us understand how these vulnerabilities affect our application. So we have our application, an SCA tool will kind of create a list of all our dependencies, something like an SBOM, and then it will then check that SBOM against the CVE databases. So there's about 5 main CVE databases. You have the MITRE CVE database, you have the NVD, you have the GitHub Advisory database, and you have multiple other ones as well. So it's really important that we understand how all of this kind of fits together. But here in this model, there is a fundamental flaw in which our research was looking at and trying to understand how can we improve the security of this flow, how can we make this better. And that fundamental flaw is that in order for there to be a CVE, someone has to report the vulnerability. So you have to, either a security researcher has to find it, or the maintainer finds it, they release an update, they disclose that there's a vulnerability, and a CVE is created. It's very, very important, because if a CVE is not created, we have no idea in our current system that that component is vulnerable. So we probably wouldn't update it. There's a saying that I'm sure every software engineer is familiar with. If it's not broken, don't fix it. And so if your application is working and a new patch has been released, and maybe updating to that latest version is going to break everything, so let's not do that. If, however, there's a vulnerability, then you're probably going to update to the latest version. So it's really, really important that those CVEs are created. However, often they are not disclosed. And there's lots of reasons why it'd be not disclosed, but often, if a maintainer finds a bug or a vulnerability themselves, they won't go through the process of reporting that. Now, there's some kind of legitimate reasons for this, but not really. And it's kind of called, officially it's called silent patching. I'm trying to rebrand it to shadow patching, simply because I think it sounds way better. So I'm going to continue with shadow patching, but officially silent patching is the name of this, of here we do. And it may be because you have fear of exploitation coming up. It's probably mostly because of reputational concerns. You're worried that by having a CVE report on your project, it's going to damage the reputation of that project. Maybe you lack resources. If you don't have policies, security policies in place to be able to do this. Maybe there's a belief that, oh, this is minor, no one's found it yet. If I just quickly patch it, it's all just going to go away. No one's going to find out about it. And then my favorite is my dog ate my CVE report. It's about as good an excuse as any, really. But to be honest, there's no real good reason why you shouldn't report a vulnerability, because the whole internet relies on the transparency of open source. And because it's so difficult to understand how that open source fits together, if we don't understand that we have vulnerabilities in there, we can be exposed. And so now this kind of comes to how we've started looking at trying to solve this problem using AI and leveraging LLMs for this. So we are launching Aikido Intel. Now, Aikido Intel is not a product. I can't sell you. I can sell you other stuff, but I can't sell you this. This is just a research project. And Aikido Intel is basically a kind of a new vulnerability database that's looking at vulnerabilities that have been shadow patched. Vulnerabilities that have open source projects that have vulnerabilities, but they haven't been disclosed properly for them. So how Intel works, and then I'll show you some of the things that we found from Intel. So currently we monitor around about 5 million open source packages. These are the most common, most popular packages. It's also the packages that is most important to a lot of the Aikido customers that we have. So we're monitoring about 5 million continuously. And what we're monitoring specifically is change logs and release notes. And we're using an LLM model, or LLM modules, to read these release notes, to read these change logs, and try and understand if maintainers have silently patched vulnerabilities that they are not going to then disclose. So there's two models that we use. The first one is data collection. So from these 5 million projects, we're collecting all of this data from the change logs, from the release notes. We're cleaning that up to remove the irrelevant data so that the next LLM that looks through this has clearer objectives. The next LLM is scanning for vulnerabilities, looking through those to try and understand if vulnerabilities have been made or fixed. And sometimes it's very obvious. Sometimes it's literally cross-site scripting vulnerability solved, but more than often it's not. More than often it's very ambiguous and it's not explicitly saying it. So we have trained these models specifically to understand the context of that and to look into different types of elements where it may not be so obvious that it's fixed. This gets us a whole lot of data that we then we check this against the CVE database, against vulnerability databases, 5 in particular, and we make sure that those problems that have been discovered by our LLM models are not already disclosed. Once we're sure that they're not disclosed, a security engineer will actually look through those manually. So there is a human in the loop. We can't solve all of this with LLMs and AI just yet. We need a human that understands the context, that can look at the vulnerability, that can recreate it, that can do analysis on it. So it is quite time-consuming for our research team, but it's a very important part. However, if we were to try and do this without LLMs, we would need thousands of people. So the LLMs make this for the first time possible. And if I'm being honest, it's probably only possible in the last 12 months because the LLMs themselves have become small enough. They don't require so much computational power that we're able to do this at such a scale. And we are adding more packages into this. So currently we're monitoring about 5 million, but obviously we're adding more and more, and that list continues to grow. So we started doing this last year. We've been doing it for almost exactly 12 months. We started in January. And I guess the next part is, what did we find? Did we find any vulnerabilities that we had? And I missed one last important step, is that the security engineer, the part of having human in the loop, we feed that back into the LLMs. So the LLMs are almost always improving. So far this year, we found 511 vulnerabilities that were a shadow patch. So 511 projects that had vulnerabilities inside them that were never disclosed. So 171 of them were low severity, but 56 critical vulnerabilities and 105 high severity vulnerabilities. So this is actually, although the numbers may not sound a lot, this is really quite significant that we're able to find this many vulnerabilities. And part of that is because of some of the packages of which we've found these vulnerabilities inside, which I'll share with you in a bit, but it's a little bit concerning to say the least. Now the next question is, okay, out of those 511, do they all not have CVEs against them? Were they all just silently patched, or were some of them, was the CVE released later on? Was it being reviewed? So 67% never got a CVE against them. And that includes either the maintainers giving the CVE or a security researcher also finding this and assigning it a CVE. So it is still a very high number. Now, if you look at this, obviously the low severity CVEs, the low severity vulnerabilities that we've found, that bumps up that number. But the most shocking one for me is that 56% of the critical vulnerabilities that we found, that we validated with our security engineers, were never assigned a CVE. They were never disclosed, which means most people will not know if these vulnerabilities actually affect them, which is quite a scary thought when you consider how bad supply chain attacks can be, because you only need one, like a log4j, to bring down everything. So, yeah, a little fun fact, the shortest time to a CVE was 1 day. Not that surprising, we had a lot that were kind of quite quickly, but the longest that we had was 9 months. So I don't think that one was going to be reported by the maintainers. That one was found by a security engineer, but they can happen. So I maybe have some hope still a little bit of hope that some of these 67% might get CVEs against them in the future. But we can have a look at them and look at some of the more interesting ones that we found. So this one here I found particularly scary. So this one is from Axios. Axios is a promise-based HTTP client. So Axios has 56 million weekly downloads, so it is a very significant project, right? We're not talking about Bob's open source homework from school. We're talking about very serious companies. This, also a fun fact, if you actually look at the number at the top, this is the vulnerability number that we give them, the Aikido 2023-0001. The reason why this is 00001 is because it is literally the first one we found. Which you can imagine the moment of finding that as the first one. But it's also one of the worst that we still found. It was found in January. There is still no CVE against this one. So this is still not a reported vulnerability yet. It is in our database, the Aikido database, but it's not in any other vulnerabilities. Another one, this one here was not so significant, but what I found significant was who the maintainers were. So this is Apache eCharts, maintained by the Apache organization. This is a medium vulnerability for cross-site scripting. Again, about 1 million weekly downloads, and this still does not have any CVE against it. So I'm showing you these ones because I want people to realize that this isn't just a lonely guy in Nebraska that isn't assigning CVEs when they're fixing something. This is actually kind of proving to be a bit of a systemic problem with a lot of companies that are out there. And it may not be malicious intent. Developers are very busy. It can just be that they forgot, that they didn't report it, they didn't think it was a problem, but it's still very concerning for our software supply chain security. And the last one I'll look at is StatMic CMS, which is a Lavrel CMS Composer package. So this one here has nearly 2 million installs, and this was a critical vulnerability that we found. And again, this one has no CVE against it, and this was a path traversal vulnerability that we found. So lots of interesting stuff. So these are just a couple that I looked at from the 511 that we found, but it is quite a concerning trend that we're seeing, especially when you look at how big some of these packages are. So now that brings me, I can kind of show you Intel and what it looks like. So Aikido Intel is a database. It's at intel.aikido.com. We have an RSS feed right now, so if you want to tap into this data, you can. You can also search through it. You can see the latest ones. So from December 11th is the latest one, which was the critical. You can search through it, find the different projects that you have, or you can plug it into your tooling if you want to understand if this affects your systems and your software itself. And just a small plug is that Aikido does have SCA, obviously, in our product suite, and all Aikido customers are protected by the Aikido database as well. So if you're concerned about that, again, you can come see me at the world's hardest to find booth, which is in that direction in Startup City, way down the back. So what's coming next for Intel? We are going to keep improving it. We are kind of going to keep building out the number of packages that we have. If there's a particular package that you need, then you can actually request that. We have an RSS feed now that is done. We're looking at creating a REST API. And I think importantly, we're also looking at open sourcing our findings. So we'll have a JSON file that is open source that you can edit if you've found something, if you want to contest one of the challenges, or to add a CVE if something has been created there in the future, so that we can kind of help build and grow it with the community. So that's all I had. I finished exactly on time, so I'm happy for that. I'll be happy to chat to anyone, ask questions. I'll be down the booth. Again, world's hardest to find booth, Startup City, way down the back. Just keep going. Eventually, you'll stumble across it. I'll be there, and I'll be happy to have a chat with you then. So thanks all for coming to the talk. I appreciate it.